In this part of the section, we're going to turn it around and go the other direction. Instead of taking a particular interval and finding the probability of falling in it, we're going to go the other direction and say, here's the probability, I want to know where the cutoff would have to be for that. And for this we also have a calculator program. It was the one right under normal CDF when you go into the distribution menu. It's called inverse norm, inverse for reversing the direction. Now that we have both directions, it can get a little confusing knowing when to use which one. So just a visual here, if you have an x value or an interval and you want the probability, then you use normal CDF. If you have the probability and you want to know what the interval needs to be, then you'll use inverse norm. With these problems, you'll still draw the picture and you'll label the mean and make sure you know what the standard deviation is, and then draw the picture to figure out which portion it is that you're looking for. Now, inverse norm always goes to the left, so we'll talk a little bit more about that, but first thing you'll need to do is get that picture drawn and figure out where exactly you're looking. Then once you have all that figured out, you'll go ahead and find inverse norm in the calculator. It needs to know three things. It needs to know the area to the left of the cutoff that you're looking for, so area or probability. It'll always be written as a decimal. And then it also needs the mean and the standard deviation with commas in between. And the rounding on this, these aren't probabilities, these are x values. So we're going to go ahead and round these the same as the mean and the standard deviation that are given in the problem. So we're going to go one farther than the original data, though you often won't have that original data, so you have to use the mean and the standard deviation in the problem to help you decide. And like with the normal CDF command, if you have the newest versions of the TI-84, you may get a little pop-up screen like this when you choose inverse norm, so don't let that throw you off. It's the same three things: area to the left, mean and standard deviation. Go to paste and hit enter, and it'll paste those numbers into the command screen for you. So we're going to look at some generic examples to kind of get an idea how this all works. Do keep in mind that we know that half of the curve is 0.5. You won't actually use that in any of the calculations though. It'll help you draw your picture, but with inverse norm you will not have to do any of the 0.5 plus or 0.5 minus that we had to do when we were finding the probabilities. So for example, we can use the idea of 0.5 just to get our picture right. So let's say we're trying to show a picture where we're looking for an x cutoff that has a 0.05 area to its left. So that would be 5%. So I need to figure out which of these pictures makes more sense, the one on the left or the one on the right, if I'm looking for 5% of the curve to be to the left of the x value cutoff. Well, 5% is a very small amount, so it shouldn't be the one that has more than half of the curve shaded in. It would be this one, the one with just a little bit shaded in to the left. The x value's far enough over that there's just a little piece to the left of it. So if that's what I was looking for, that cutoff right there that only has 5% less than it, then I would do inverse norm. I would tell it that I wanted 0.05 to the left, and then I would type in the mean and the standard deviation, and then that would give me negative 5.5. And the mean and standard deviation in the problem both went to one decimal place, so I will as well. So how about this one? I want the x value that has 0.67 or 67% to the left. Well, that one's more than half, so my x cutoff would be past the halfway point, so that when I point to the left, I'm shading in more than half of this curve. Just eyeball 67%. It doesn't have to be perfect, you just need to get it on the correct side. So if I'm looking for this one, I'd say, okay, inverse norm. I want 0.67 to the left, mean and standard deviation, and that would give me negative 0.7, again rounded to one decimal place the way the mean and the standard deviation are. You may notice when you're checking answers in the back of the book, they usually do it this way. They're not 100% consistent on that, but that's the rule that you should follow. Match it to the mean and standard deviation that you see in the problem. But here are the ones that we need to be careful with. So let's say the problem I'm working on, I need to know the x value that has 0.7 to the right. So that would be 70%, but I want 70% to be to the right of the x value. So first of all, which picture would that be? It would be this one, with more than half being to the right. So from the right, I have to come more than halfway over so that I have about 70% to the right of the x value. Well, once we've got the picture, we need to think about how to put that in the calculator, because the calculator only goes one direction. Inverse norm will only calculate the cutoff from the left. So we need to think about that. If I have 70% to the right, it's a total of 100%. So if I have 70% to the right, that leaves 30% to the left. That's what I'm actually going to have to tell the calculator, because it always calculates from the left. So when I put that in the calculator, I'm going to put it in as inverse norm 0.3 and then the mean and the standard deviation, and that'll come out to negative 2.9 degrees on this one. All right, so what if we want 20% to be to the right? Which picture then? Well, that's telling us we just want a little bit to the right of the cutoff that we're looking for. So my picture would come over just a little bit from the right, label that 20%. But again, for the actual calculation, I need to know how much that leaves to the left, because the calculator always goes from the left. So 20% to the right, that means I've got 80% to the left. So when I actually put that into the calculator, I'm going to put it in as inverse norm 0.8, type in the mean and the standard deviation, and this time we get a cutoff of 0.2. And with all of these, you can check 0.2, does that look like it's in the right place to make sense? Well, my mean is a negative number, 0.2 is to the right of that, so that seems to make sense. Every once in a while, you'll be asked not to find one direction or the other, but to find in between. So I want to find the two values that would designate the middle 90%. So I'm going to center a pretty big chunk, and I'm going to have a cutoff on each side. So I've got an x1 and an x2. I need to find both of those. So for this one, since I'm trying to find two different cutoffs, one on the left and one on the right, I'm actually going to have to do two different calculations. So first let's focus on x1 on the left there. Well, I need to figure out how much is to the left, and I've got them labeled in this picture. Let me talk about where that comes from. So we've said that we want to find the 90% in the middle. Well, that leaves 10% for other places, but that 10% needs to be cut in half because some of it's on the left and some of it's on the right. So I've got 5% on the left and 5% on the right, so that all adds up to 100. So looking at that picture then, to the left of the first cutoff is 5% or 0.05. So to calculate that, we'd put in inverse norm 0.05, the mean and the standard deviation, and then we find that the first cutoff then on the left is negative 5.5, which makes sense because that would be to the left of negative 1.7. Okay, so now we need to focus on the second cutoff, and that one we need to be careful with. It has 5% to the right. Inverse norm needs to know how much is to the left. Well, if there's 5% to the right, then there's 95% to the left. You can also see that by adding together the 90 and the 5 that are to the left. So to the left of the second cutoff is 95% or 0.95. So to calculate that one, we'll put in inverse norm 0.95, mean, standard deviation, and so that tells us that the cutoff on the right for that middle 90% would be 2.1. So the middle 90% falls between negative 5.5 and 2.1 degrees Fahrenheit. Okay, so that sort of runs through the three basic cases, left, right, and in the middle. So now I'm going to run through and do some word problems with these to get some more practice. What you may want to do is pause, try them on your own, and then see if you did them right. Alright, so we've got a new assistance program for low-income families. This area has family incomes with a normal distribution. That means we can do normal CDF and inverse norm on this. with a mean of $24,596, standard deviation of 62.56. This program wants to target the bottom 15%, so the lowest 15%. We need to figure out what would the income cutoff be then for families to be eligible for this program. So first thing we'll do is get the picture drawn. So I've got my normal curve drawn, I've got the mean labeled in the middle. We are given a percentage or a probability. You can think of those as the same thing. So that means this is going to be an inverse norm problem. I know the area and I'm looking for the x value cutoff. So I'm looking for the bottom 15%. That would be on the left because they're going to be the lower incomes. So I've drawn my x cutoff. I've shaded in that I want 0.15 to be lower than that, so that I'm looking at the shading being the lowest incomes, the lowest 15%. Well, inverse norm finds to the left, that's what I want, so I'll go ahead and put in inverse norm 0.15, mean, standard deviation, and that comes out to 18,112. Since the mean and the standard deviation were given to me as whole numbers, that's what I'm going to round to also. So the cutoff for this program would be $18,112 or less to be eligible. So in this one we want to find the top 2%. We've got the mean and the standard deviation for the heights of females who are 20 to 29 years old, and we want to know the height required to be in the top 2% for that group. So we'll draw the picture, got the mean down the middle. This time we want the top 2%, so those would be the higher heights, the ones over on the right. Okay, so I want 2% to be to the right of that so that I'm shading in the top 2%. Well, in this case, inverse norm doesn't go that direction, so I need to figure out, if that's the case, how much is to the left. If I have 2% to the right, that leaves 98% to the left, and so that's what I actually need to put into the calculator. So I'm going to put in inverse norm 0.98 with the mean and the standard deviation that we were given, and I'm going to round to 1 decimal place because that's what the mean and the standard deviation were given to me as. So that comes out to 69.9. So the top 2% for 20 to 29-year-old females would be 69.9 inches and up. Let's do another one with that same information, but this time we're looking to make a robe that will fit 95% of these women. So when that's the case, you're usually wanting to pick right in the middle. So I want this to fit the middle 95% of 20 to 29-year-old females. So I want to know what would the cutoffs for that be. Be careful when you draw the picture. So I've got the mean coming down the middle. This time we're looking for the middle 95%, so I need to take a 95% chunk out of the middle, which means I'll have a cutoff on the left and the right. And so I need to go ahead and figure out what those missing percentages on the left and right would be. So 95% out of the middle means that there's 5% left. I'm going to have to cut that 5% in half, one for each end, and so that would be 2.5%. And when you move the decimal point twice to the left for 2.5%, you end up with 0.025. So I have 0.025 on each side. Okay, so that means for that first cutoff on the left, the percentage to the left of that would be 0.025. So for that first cutoff, I'll put in inverse norm 0.025, the mean, the standard deviation, and that's going to give me 58.6 for that first cutoff on the left. Now I need to think about the other cutoff over on the right. So that one has 2.5% to the right of it, which leaves 97.5% to the left. Or you can go ahead and add together the 0.95 and the 0.025 to get the same thing. So since inverse norm needs the amount to the left, that's what I'm going to put into the calculator. So inverse norm 0.975, mean standard deviation, gives me 69.6 for the cutoff on the right. So it looks like to make a robe tall enough to fit the middle 95%, then I would want it to fit women that were between 58.6 and 69.6 inches tall.